Welcome to lesson 2 on the chemistry of aromatic compounds. The unit code is BCH 3203. My name is Peter Karori. Now, in lesson 1, we looked at introduction and the meaning of aromaticity, and we looked at various types of aromatic compounds. In this lesson, generally, we are looking at the chapter 2 on the module on aromatic compounds. And the content of that chapter is that by the end of the lesson, we should be able to state both the IUPAC name and special names of monosubstituted benzene compounds, draw the structures when given names of monosubstituted compounds, draw the structures, give the IUPAC names and special names of benzene derivatives, and also draw the structures and give names of benzoid aromatic substituted aromatic compounds, that is compounds of naphthalene, compounds of mostly in this case we shall deal with the three simplest fused benzene compounds, that is naphthalene, Anthracene, and Phenanthrene. So we start with the nomenclature of monosubstituted benzene compounds. Now, the nomenclature of monosubstituted benzene compounds is basically simple as per the IUPAC system. You of course know the IUPAC system is this, the internationally accepted system, and IUPAC stands for International Union of Pure and Applied Chemistry. Apart from the IUPAC system, many of the compounds had already been given names prior to the IUPAC naming systems, and some of those names are still the most accepted names of some of the compounds. Now, those are what we call common names. But generally, as per the IUPAC, because that is what we can logically be able to determine, the naming follows certain rules. And rule number 1 for monosubstituted compound is that naming is in such a way that the substituent the substituent's name becomes the prefix, while then we add with the name benzene. So we look at some monosubstituted benzene compounds. So you have benzene, where you have a monosubstitution by chlorine. So we simply call it chlorobenzene. If you have bromine, then it is bromobenzene. If it is iodine, then it is iodobenzene. If it is a nitro group, nitro radical, then you have nitrobenzene, and so on. So that generally is simple. However, some monosubstitutions tend to give the name of benzene some common names. For example, if we had a methyl group substitution, we could call the molecule methylbenzene. However, the common name is more accepted, and that is the name toluene. If, for example, we had two methyl groups substitutions in a benzene ring, so we have the names styrene, but we are not going there yet because we are still dealing with monosubstituted benzenes. So rule number 2, if there are several substitutions, that now is when we have more than one substitution, then the relative positions are shown. So if, for example, you have 2, then you have to give the relative position. But the relative positions are in relevance to one of the substituents. So that substituent which we use as position 1 is what we say is a preferred substituent. And generally, the rules are that the more electronegative, the more electrodonating substituent is usually given preference. For example, if you have an amino group, it will be given preference over a nitro group because the amino group is more electron donating to the ring. Again, if you have a methyl group, it will be given preference to a nitro group. Rule number 3, when a group has a special name, then we use the parent name as the special name. If, for example, we have methyl benzene and another substituent, then we are saying that methyl benzene is toluene. Then we use the name toluene instead of methyl benzene as a parent name. Rule number 4, when 2 or more similar groups are present, then we use the prefix di, tri, depending on the number. So if it's 2, you use di. If it is 3, you use tri. If it is 4, you use tetra, etc. And then you add the name of the substituent, and lastly, the name of benzene. Rule number 5, if more than 2 groups that are different are attached to the benzene ring, so we have already talked about that one, that the preference is on the more electron donating group. But if we have related groups, for example, alkyl groups, so we give preference according to the alphabetical order, but again, the longer, the bigger substituent is usually given preference. If there is a special group, then the derivative is given the special name. I have already talked about methyl benzene being toluene. If we have aminobenzene, the molecule is referred to as anhrine. So in that case, the benzene compound then becomes anhrine, and the other group becomes a substituent if it is not a preference group. If there is an alkyl group that is branched, then the benzene is taken, that is not branched, then benzene nucleus is taken as a parent. So we're looking at some example. We have 2 nitro groups, and we have said that if you have 2 groups, then you name by using the prefix di. If there are 3, then it is tri. So if, for example, this one is a dinitro benzene. This one is, but the positions have to be given. So the position is 1 and 2. If you start with 1, then the next one is just next, so it is at position 2. So it is 1,2-dinitro benzene. Now, another important thing I want to name, to notice when you are naming substituents of benzene is that there are 3 possible other positions if you have 1 substitution. There is this position which would be equivalent to this. This is equivalent to this, and this is on its own. So we can say that there are 3 different positions that are likely. Now, if it is at position 2 on either side of the first substituent, we can use the word, we can use the term ortho. We say positions 2 are ortho positions. Positions 3 on either side are meta positions, which we represent by M, and position 4, which would be, is only 1 from whatever side you count, is referred to as a para position. So this one would be either 2 or 1,2-dinitrobenzene or ortho-dinitrobenzene, meaning that the nitro groups are ortho to one another. This one is at position 3. So these groups, this place is what we call meta. The groups are meta. So you can either say 1,3-dinitrobenzene or more preferred meta-dinitrobenzene, because we are saying simply they are meta M dinitrobenzene to one another, and so on. So now we are saying that in terms of preference, the more electron donating group is preferred. So if you have a chlorine and a nitro group, chlorine is preferred than a nitro group. So this molecule becomes a chlorobenzene, and nitro group is seen as a substitution. In that case, this is ortho nitrochlorobenzene. This one is meta-nitrochlorobenzene. So see that we have already preferred chlorine. So that is in terms of naming. Now, we have, there are also other rules. And so we have already said that if you have an alkyl group which is not branched, then the benzene ring becomes the major name. For example, if you have an ethyl group, we simply call it an ethyl benzene. However, if you have two alkyl groups, one which is longer than the other, the longer ring is taken as the main ring, substituent, the other one as the main. So if, for example, you have a propyl and an ethyl group attached to benzene, say in another position, then I'll call that benzene although ethyl propyl benzene, meaning that I have given preference to the longer substituent of the alkyl group. If the alkyl group is blanched, that is an important point to note. If the alkyl group is blanched, then the alkyl substituent is taken as a parent, and the benzene ring is now seen as a substituent, not the alkyl group. We look at that. If the chain is branched and benzene ring has further substituents on it, then the branched chain still is taken as a parent. So we are saying that a branched alkyl ring, alkyl group is given preference. And I'll just give one example. Now look at this. So this is a benzene ring bonded to 1, 2, 3, 4, an 8 carbon alkyl group, meaning an octane, which would have been an octyl group. However, so if it was not branched, we would have called this one octyl benzene. However, because of the branching at position 1, then we say that, so we start counting here. So at the position 1, this is blanched. So we look at this as the main ring and benzene as an attachment. So in that case, it is benzene being attached at position 2. So instead of saying that this is an octyl benzene, we say that this is 2-phenyl octane. So we are now looking at benzene as phenyl is the term used for a benzene that is lacking one hydrogen as a substituent. So that is now the benzene ring becomes a phenyl substituent. So these are things we had said, that two methyl groups makes the name change to xylene. So these are common names. Moving on. Now, so we have looked at the naming of benzene. Now we look at the second benzoid, the simplest fused benzoid molecule, and that is naphthalene. Naphthalene has 2 benzene rings fused and has 10 carbons. However, we had earlier seen that when we are numbering naphthalene, we number only those carbons that are not in the position of fusing, because those at the position, the 2 at the position of fusing cannot be substituted. So we number from 1, 2, 3, 4, 5, 6, 7, 8. Going back. So in the nomenclature, the bridging carbon atoms are not numbered. So that one I have shown. The carbon atoms are not equivalent. Naphthalene introduction of substituent gives 2 isomers. So if depending on what position a substituent is introduced, we can look at a substituent being in one position which would have originally been seen as equivalent, but then if there was an original substituent, then that substituent will be a different isomer. then if we substitute more than one, the numbering follows the order of the numbers as I had already shown. So we number from one ring up to 4, then we jump the fused carbons, then we number. So naphthalene has 8 carbons that are numbered, so we can give a substitution as being either in position 1 to 8 in a similar way as we do to benzene. So if in this position we have a methyl group, then it becomes 1-methyl naphthalene. If it is in this position, now because they are not equivalent, we are looking at position relative to the position of fusing. Then although it is 1, then it becomes 2-methyl naphthalene. If it was in a benzene ring and you have only one substituent, that substituent is always in position 1. But here we can have different positions depending on where the substituent is attached relative to the way we number. Then we go to Anthracene. Now this is a 3-fused ring where the rings are fused linear to one another. Again, I'll show the numbering. So in the numbering, we start with one of the terminal ring, numbering as 1, 2, 3, 4. Then we jump the middle ring, and then we number continuously to the other extreme head ring, 5, 6, 7, 8. Then the 2 positions at the middle which can be substituted are numbered 9 and oppositely 10. So, for example, this one, because we are starting counting from this, but this can also be 9, so long as, if for example we had 1 here, then this would have been 9. But because there is no other substituent, then we can also consider this as position 9. So it becomes Anthracene 9 all. If there are 2 substituents in this position, then this is 9 and 10, Anthracene 9, 10 diol, and so on. So we have, again, these are 9,10 dinitro-anthracene. This is position 1, 2. So we have sulfonic group at position 2. Then 3, 4, 5, and 6. So these are positions 2 and 6. So this one would be Anthracene 2,6-disulfonic acid. Then now we go to the third benzoid structure, that is phenanthrene. Again, it has 3 fused rings, but they are not linear to one another. So let's go to the structures themselves. So in that case, we can look at phenanthrene as being very similar to anthracene, only that instead of positions 9 and 10 being opposite, at the middle carbon, the positions that can be substituted, which are still 9 and 10, are adjacent to one another. So in that case, for example, this one can be seen as 10-hydroxophenanthrene 9-on. So there should be an OH group there. No, this is 10-hydro, meaning because here the ring there are 2 hydrogens. That is why we are saying here there would be 2 hydrogens. That is why it is 2-hydro, meaning that there is a hydrogen substitution in position 10 and a carbonyl carbon in position number 9. So it becomes 10-hydrophenanthrene 9-on. Again, here, what is that, here we should have had a double bond. So meaning that here we have 2 hydrogen additions in position 9 and 10. So it becomes 9,10-dihydrophenanthrene. So if, for example, we look at this one, we can look at numbering as starting from 1, 2, 3, 4, then 5, is it? No, it should be 1, 2, 3, 4, 5, 6, 7. So it is, we have chlorines at position 2 and 7. That then means that it is 2,7-dichlorophenanthrene. So having looked at anthracene, then it is easy also to derive the nomenclature of phenanthrene. So, that generally gives us, brings us to the end of looking at the nomenclature of benzene and benzoid compounds, that is benzene, naphthalene, anthracene, and phenanthrene. So exercise questions that can help you to assess your understanding. Draw the structures of the following compounds. That is, all these questions are in nomenclature. 4-cyclohexyl anisole, 3-methyl-phenyl benzoate, 3-bromo, 5-nitrobenzene sulfonic acid, 3-chloro, 7-fluoro, 1-naphthol, 2-amino, 4-butoxyphenyl, 2,7-anthracene disulfonic acid. So from what we have looked and in reference to module notes, then we should be able to accomplish that. That brings us to the end of lesson 2, and thank you.
We are in a digital era, and Mount Kenya University knows this. The following are the steps to follow so as to complete your online application. Download the application form from the website www.mku.ac.ke. Attach copies of your academic certificates and ID. Pay the application fees via M-Pesa pay bill number 270988. Your ID is the account number. 2,000 shillings is the charge for a postgraduate. You can also deposit in the bank accounts provided on the website. Then, email all the above to apply@mku.ac.ke.